Hi everyone, Mary here, and I want to thank you so much for reaching out to me and asking this question about centripetal force. It is tricky in our physics problems kind of figuring out which force is the centripetal force. So let's talk about this for a moment. Now, to review some, a centripetal force is any force that acts towards the center of a circle. The word centripetal means center seeking. And so if an object is undergoing a centripetal force, that means that it's going to be traveling either in a circle or in a partial circle, like in an arc or a curve. The thing that makes this sort of tricky is the fact that centripetal force is actually caused by one of the other forces that you and I have already been dealing with. Friction force, sometimes it's gravity, sometimes it's going to be normal force, tension in a string, and even in some situations it's going to be electricity or magnetism. It's kind of like the analogy that every woman who has a child can be called mom. And that's not her real name. If she went to go get a driver's license, her driver's license would not say Mom on it. Her driver's license would say Doris or Pang or Elizabeth or whatever the heck her name happened to be. But this is a generic name for ladies with babies. The generic name for any sort of force towards the center of a circle is centripetal or centripetal. So the trick in order to do the physics problems is we have to figure out which specific named force is causing the circular motion. So let's look at a couple common examples. Let's start with a car that is on a curved section of road. Now, if you're driving on a curve, you know that it's friction that holds your car to the concrete or the asphalt, the friction between your tires and the actual road itself. If you are going on a curved path, the friction force is your centripetal force. Once you have that identified, you can start replacing these with equations we already know. So friction force can be replaced with mu times normal force, and centripetal force can be replaced with mass times centripetal acceleration. Now we can take some data, now we can plug some things into equations and solve for our unknowns. Here's another real common example. Let's say that we have a satellite that's circling the Earth. If the satellite is circling the Earth, it's going in a circular path. There's got to be a center-seeking centripetal force. And what powers things in orbit? Well, it's gravity, of course. So as soon as we have figured this out, that one force, centripetal force, is the force of gravity, then we can replace these pieces of information with items from our equations. Mass times centripetal acceleration can equal Newton's universal law of gravity, g, mass 1, mass 2, divided by the radius between the centers squared. I hope this helps you a little bit. Please keep reaching out if you've got questions. It makes me really happy when I can be of assistance. Have a fabulous day. Bye-bye.